Alright guys, welcome to this video lecture. Okay, because of this scary coronavirus, we have to do these things. But I think you will not have much problem with this teaching method too. But if you have any question, you can always email me or call in my office number, right? So last time we were talking about limit at infinity. That was section 3.5. Okay. From the book. But before I start what we discussed in the last class, what I want to ask you is I want to ask some of the questions. For example, what do you think if you divide 1 by infinity? What do you think? How much would that be? Meaning that you are dividing 1 by very big number, so it is almost 0, right? Similarly, if you have 1 divided by negative infinity, this is also 0. So not only 1, if you divide 2 by positive or negative infinity, it will be 0. Meaning if there is a c, if c is not infinity, but if you divide c by positive infinity or negative infinity, that will be 0. That's one thing that we need to keep that in mind. The another thing is, suppose you have, say for example, 1 over 0 is how much? What do you think? This is infinity, right? This can be so because when you go 0 from the left, you will get negative infinity. If you go to 0 from the right, you will get positive infinity, meaning the number will be big like that if you go from the right to 0. If you go from left to 0, it will be like small from negative infinity. Basically any number divided by 0 will be positive infinity or negative infinity. If c is positive, then it is positive. If c is negative, then it will be negative infinity, and so on. How about this? Do you know how much is 0 over 0? We don't know, because you cannot cancel 0 and say 1, because 0 cannot be cancelled, right? So we don't know. We call indeterminate form. We will discuss that in the next chapter. How about infinity over infinity? Or negative infinity over infinity, positive infinity over infinity, positive infinity over negative infinity, it doesn't matter. But if you have a infinity on the top and infinity on the bottom, we don't know this. So this is also indeterminate form. Okay? Let me ask you one more. How about this one? Infinity minus infinity. This is not 0. The reason why it is not 0 is because we don't know how much is infinity. It can be like 1 over 0, this can be 2 over 0, both are infinity, right? And then 1 over 0 minus 2 over 0 cannot be 0. So we don't know that too, so it is indeterminate form. And again, we will discuss more about the indeterminate form in section 5.6, which is the next section. So now let's review what we did in the last class. In the last class, what we did is we tried to find out limit at infinity when the numerator function and the denominator function both were polynomial. What do you mean by polynomial? Polynomial is a function that has all the exponent either positive whole number or positive integer or 0, right? In that case, how did we find the limit? So how did we find out the limit x tends to infinity if there is like fx over gx? How did we find out the limit? Is if the numerator, if the top has degree less than the denominator, then the limit is 0. If the numerator has a degree equals to the degree of the denominator, then the limit x tends to infinity, fx over gx will be a ratio of leading coefficient, right? That's what we did. And if the numerator has bigger degree than the denominator, then in that case what we did was the limit will be does not exist or infinity, right? So that was the case that we discussed last time. So but how do we find out the limit if the numerator or the denominator or both are not a polynomial? For example, if they have the root or if there is like sine x, cosine x, that type of functions, then how do we handle that things? So for example, let us try to do question number 25 from the book. Okay, so this is limit x tends to let me see negative infinity. The question is x over under the root x square minus x. Look at this. The numerator is a polynomial, but the denominator is not a polynomial because it has a root, right? How do I find out the limit at infinity here? So what we do is limit x tends to negative infinity. Then what we do is x is in the numerator, there is just x, so you don't do anything. But what we do in the denominator is try to get the factor, or try to take the maximum exponent out. So the maximum exponent here is x squared. Let's take that out inside. So what is left is 1 here, right? Minus what is left here is basically x over x squared, right? So this becomes limit x tends to infinity and negative infinity x over this x squared comes out as x because this is like product. You see that? So x squared times that, so you can distribute that root like root x squared and then times root of that, right? So and then times that will be 1 minus x, and one of the x cancel out, so you'll have 1 over x. Now you see that cancel out, so that becomes limit x tends to infinity negative infinity. What is left is 1 over 1 minus 1 over x. By the way, I forgot to tell you what would happen if you plug in the limit directly. You will get negative infinity divided by, it will be like negative infinity square is basically positive infinity minus negative infinity will be infinity. Look at this. If you plug in the limit directly, you will get that form. So we don't want to plug in the limit directly. So let's plug in the limit right here. What you get is on the top you get 1, on the bottom you get 1 over 1 minus 1 over infinity. It will be 0, right? Positive infinity, negative infinity. If you divide a number by infinity, it could be positive or negative infinity, you will get 0. So basically you got limit is 1. That's what the limit is, right, for this problem. So what did you learn from here is the basic idea is if the numerator or denominator, one of those numerator or denominator is not a polynomial, then you try to take out the common factor or the maximum factor from the top, maximum factor from the bottom, and then you cancel out. Okay, let's do one more example. Let's do number 29. On question number 29, I have limit x tends to infinity, limit x tends to infinity, and it is root x squared minus 1, root x squared minus 1 divided by, you got x squared, 2x minus 1, not x squared, 2x minus 1. So let's plug in the limit right away. So if you plug in infinity, you'll get infinity squared minus 1 is infinity, and root infinity is basically, you get infinity divided by 2 times infinity is how much? That is infinity minus 1, infinity. So you got that form. So meaning we don't plug in right away. So what we do, we try to simplify. What is the highest exponent term on the top? It is x squared. So let me write down limit x tends to infinity. I am taking x squared out from the top. What is left is 1 minus 1 over x squared, right? And divide by, what is the maximum exponent of x? That is just x, right? X to the 1. So what is left is 2 minus 1 over x. There is a benefit of taking the common thing out, because when you take this out, you will get x and cancel with x. And when you plug in the limit for the remaining, you will get 1 minus 1 over infinity, that is 0, and 2 minus 1 over infinity, that is also 0. So it will be 1/2, right? That's what you will get. So limit x tends to infinity. So let me take that x squared out and write down x. 1 minus 1 over x squared divide by x, and then 2 minus 1 over x. That's what you get, right? So you cancel out x and then x. Now plug in the limit. You will get root under 1 minus 0 because 1 over infinity is 0, and then 2 minus 0, that is basically 1/2. That's what you get, right? So in this problem, the numerator was not a polynomial. And sometimes you will see a problem that doesn't have numerator and denominator, that has just one line, meaning you don't have 0 over 0 or infinity over infinity, but you get infinity minus infinity form. Okay, let me do question number 43. In question number 43, we have limit x tends to negative infinity, limit x tends to negative infinity, and then you do x plus under the root x square plus 3. Let's plug in the limit right away. Negative infinity, there is negative infinity, and then you will get, like, if you plug in the limit directly, you will get negative infinity plus, if you plug in negative infinity for x, you will get negative infinity square, that is positive infinity. It will be like this, right? Negative infinity square plus 3, that's what you get, right? So how much is that? That's basically negative infinity square is infinity plus 3, right? You get basically infinity. So what you get is negative infinity plus infinity. So which is not good form, which is an indeterminate form too. We will see that in the next chapter too. But this is indeterminate form. We don't know, this is not 0. You can cancel that because we don't know what is infinity. That's why. So in this case, if you remember that from chapter 2, we do conjugate multiplication. Limit x tends to negative infinity. If there is no denominator or if there is no numerator, nothing in the numerator, sometimes in that case we do the conjugate multiplication. X plus x square plus 3. And what will be the conjugate of that? What do you think? So the conjugate of this will be basically x minus x square plus 3, right, divide by x minus x square plus 3. That's what you get, right? You see that there is 1 in the denominator of this. It is like a plus b, and it is like a minus b. We have a and b, same thing, right? But what is the product? The product will be, if you multiply a plus b and a minus b, what do you get? You get a square minus b square, right? That's what you get. So if you multiply that, what do you get then? That will be basically limit x tends to negative infinity. You will get a square minus b square, that will be x square minus root under x square plus 3, and then square, a square minus b square, divide by, if you multiply something by 1, you will get the same thing. So x minus x square plus 3. That's what you get. Now what happens to the top is limit x tends to negative infinity, and then you get x square minus, because that root square is basically root and the square will cancel out, so you'll get x square minus 3. Do you know how I got minus 3 here? Because you distribute that negative sign to both of them, negative x square and then minus 3. Divide by, so basically you got a same thing, x minus under the root x square plus 3. You see that? Okay, now you see that there are plus and minus, x square cancel out. So what is left here at the end is limit x tends to negative infinity. You got negative 3 divided by x minus root x square plus 3. Let's plug in the limit now because there is no x in the numerator. So you get, this will be negative infinity, right? This will be negative infinity, and then minus, this will be x square is negative infinity square is positive infinity as we saw before, plus 3 will be infinity, so that will be infinity, right? So basically negative infinity minus negative infinity will be negative 2 infinity, basic, that is negative 3 over negative 2 infinity will be 0, right? Because whenever you have a number divided by infinity, you will get 0. So it is basically negative 3 over infinity. You see like that, negative infinity you can say. So that will be basically positive 0. That is the answer for this problem.